Hello, in this video I will speak about Tesla Radiant Energy, so Tesla at last. Before I start to speak about it, I want to remind you that Tesla used to say that he always tried to put the biggest energy which he can produce in a small place. When he doing that, other thing is come on the surface. So he used this principle, very simple principle, during his work with Tesla coils and with Tesla turbine. I will describe this principle on a very simple circuit. This is a source, it is a resistor. So by ohmic law, relationship between them, the voltage is resistor times the current. So in this case it is DC source. So when we apply the voltage to this resistor, we can see relationship that lower, for the same voltage, lower value of resistor gives a bigger amount of current, and opposite. But it's not all what's happened here. When we apply the voltage to the resistor, around the resistor are small particles of air, ions. There are so many around, and they act like capacitors. So when we, in the moment, because the capacitance of these ions is too small, when we apply the voltage in this moment, we charge these capacitor ions, but this amount of energy is too small to put into account. So that's why we do not put in account, and we follow this formula. When we have instead DC, we have AC current source. Something similar is happening. In first half period, it's these ions charged from this side in order from another side. But again, until the frequency is too low, this amount of energy is too small, and current pass, let's say the resistor is primary path, and energy which pass through ions is secondary path. But if we increase the voltage and the frequency, then more and more energy will go through this path where is the ions. So, and if we also increase the resistor, value of resistor, in that case energy path through ions will be primary path, and through resistor will be secondary path. So, and if you use this formula now, we will find that bigger value of resistor gives bigger current, which is not this ohmic law. Tesla described it in his when he lit the lamp. He's on the beginning of his work. He has filament by carbon at that time, and when he applied high voltage, high current, then and it's low pressure, more energy and current pass through this pad, and it makes white glowing of old chamber, but very small energy pass through the filament. Later Tesla used just one terminal, because he used new principle, one terminal. There was some semiconductive body. It could be conductive, and when he applied high frequency, high voltage, so the ions bombard very fast this body and it produces the light. Tesla had problem to find material which will last longer, because any material which he used in that time he destroyed. It was interesting for me, and Tesla also said that discharging from his Tesla's coil is actually DC nature. I made some tests a long time ago where I used secondary coil of Tesla coil. It was plywood, it was nails, which I nailed about 5 centimeters apart. Distance between them, it is about 2 inches. And I noticed when I approach with neon tube to first nail, and there was arcing to neon tube through my body to the ground, and it was, let's say, a little painful. But how I approached to next and next and next nail, it happened that it was arc. Let's say when I to second nail, and from second forward to neon tube which I hold, and I notice every time when I go step back that I receive felt very painful discharge through my body. I tried to explain that, and then I made it will be top view. I put about 10 discs. I will not dry. First one is connected to Tesla secondary coil. So last one is to the ground. And I noticed that on the beginning the arcing was tiny, but it was thicker, thicker, and thicker and thicker. How it goes to the grounded disc. It tells me that must be potential, that it looks like DC current. So to prove that, I used some ball, like spherical sphere, like which radiate, and this radiation, and I put the plate which was connected to the capacitor and back to the ground, until I was in the distance where there was arc, visible arc, from the terminal to this plate. I had nothing here, no voltage, because it's charge discharge. This movement of ions in the air are asymmetrical. So when I put where there wasn't visible arc, then I received the charge in this capacitor to very high value. Of course, when I distance forward and forward, the current was smaller and I needed more time to charge. I knew it is, maybe everybody of you know that. Then I made something different. I put high value of resistor, let's say about 600K, then capacitor. I will draw capacitor how physically it looks now. I will explain why. It was 15 nano capacitor, then resistor again, then capacitor again, and I put so many of them in line. And it is simply wire which finish. Let's say there was 10 or more of them. Because high value of resistor, it acts like small spark gap, because in the you can see the arcing here, and arcing here. But the surface of this capacitors is plastic, so there is also similar, like here. It is ions moving in here and here and so on. After, when I stop and make measurement, I noticed that it was there was DC voltage, and this is the smallest value, a little bigger, and bigger and bigger. So I got affected as I more distance. The capacitor is more distant from Tesla secondary coil, has more voltage inside. Then I put spark gap here across all it. So when I switch on the Tesla coil again, I had arc also here, and I got for the same period of time I got much more voltage, but all of them was the same by putting this capacitor spark gap. Then I try to see does some material can increase charging capacitor on that way. Let's say it is material A, it is material B, and it is the capacitor, collecting capacitor. It doesn't have to be Tesla coil, it could be any high voltage secondary coil. I have found that if I use carbon or graphite here and any other material here, it could be tungsten, copper, or iron or matter, then I can collect DC charge here. But also I have noticed if it is carbon B material, carbon, in this case carbon on grounded side, it works better than if it is carbon and it is iron, let's say. But also what I notice also that if I use carbon, this side is always positive. Here will be small presentation of it. So it is standard flyback transformer, high voltage, battery, ampere meter, collecting capacitor which is 40 microfarads. It is high voltage, output is grounded terminal. So I put tungsten rod on the high voltage output. In this plastic cap I put active carbon lamp, which connected to capacitor, and capacitor is to ground terminal. Over here we can read the voltage in capacitor. Just in case we can follow on the scope. So it is 50 volts per row. So let's see what we'll get. If we can see that it's rising. Also we can see on the scope it reached some level, and perhaps in that case it cannot reach forward because the current goes back and forth. So if we stop, so it's not it's real DC power, not by, let's say, discharge. In next video I will speak about application of this effect. Thank you for watching.